Alright guys, let's take a look at this section. This is 5.5, and in the last section we talked about exponential growth. In this section we will talk about logarithms, logarithmic growth and such. So this first one, we're going to find the exact value of x of a given logarithm. Now notice this is written as ln of x equals 38, which means natural log of x equaling 38. Before we solve this, I want to show you something on a TI calculator that I just pulled up here. If you look at this ln button, and right above it you see this e to the x, this might be a little bit of an indicator to you that, hey, you know what, we've got inverses of each other. Alright, so remember that, okay, e to the x. I'm going to keep that thought in mind for just a minute. So if I have this natural log of x equal 38, then we had that e to the x we were talking about, right? So I went ahead and I calculated it. Remember, it's e raised to the x. If I place an e to both sides, what that does is that e to the x thing, you remember, on the calculator, and this guy, our ln of x, ends up in the exponent, and on the right side, the 38 ends up in the exponent. So it's still got equivalent statement here because my bases are still the same. But what that does on the left-hand side is when you have e raised to the ln, they neutralize each other, right? Because they're inverses of each other, so that just drops you down to an x on the left side. On the right side, well, e to the 38 is our answer, as it turns out, and they're asking for the exact value, right? They're not asking you to round or anything like that. If you did, then you'd use your calculator and use the e button, probably second function e, and figure out. It's a huge number in this case, so I'm glad they just said e to the 38. That's going to be your answer. In fact, let me enter that in, e to the 38. That guy right there. Let's see. I think if we type in e and then this exponent thing and then do 38, that's probably going to be what we need. There it is. Hope that one helps. Let's move on to the next one. Okay, I think I can do this one straight up without having to prep. Basically what's happening here is we've got the sound intensity formula going to equal 10 times the log of your I over I naught. Now what that is the I naught here, that's your initial intensity. A lot of times they just assume that being a 1, which that's what I'm going to do. I'm just going to call that a 1 and ignore it. This guy though is your decibels that we're talking about, so 90. So what we're doing here is we're taking the log of 90, whatever that is, and multiply it by, you stinker, by 10, and that'll give us our answer. So the number of decibels that we're talking about here is, I'll do it real quick, the log of 90 times 10, we are looking at 19.5. Oh, nearest whole number, so let's just go, so it's 19.5424 dot 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 dot. So they want to call this guy, you know what, I'm going to write approximate equals approximately that. I just don't want to go find my double tilde because I have to go pull up an equation editor and all that. But long story short is we're rounding this to 20. Okay. Oh, you got to be kidding me. Okay, hang on. Let's find out what we did wrong. Hold on just a minute. All right. I totally messed this up, everyone. But let's learn from my mistake. Not the way to do this. Where did I mess up? And I cannot believe I fell for this. But like I said, we're going to learn from this and figure out what I did wrong. Hopefully you already spotted it. The blender is 90 decibels. It's not an intensity value. All right, my 90 should be over here. So this is the way. This is embarrassing too. All right, so what we're going to do is we're going to take 90 and set that equal to 10 times the log of, really it is just I. because I0 is just 1. So don't worry about that. All right, so what we're going to do is we're going to divide by 10 right away. So we're going to end up having 9 equaling the log of I. Now the question now is, how do we solve for I? So give me just a second while I pull up a certain formula. All right, I am now set up. So 9 equals the log of I is where I left off. Now, if you don't see a base there, assume a 10. So this, another way of writing this would be 9 equals the log of base 10 of I. Now what we're going to do is use this formula here. Y equals the log base A of x is the same thing as x equals a to the y, or they're logically equivalent. So basically what's happening here is I've written this as an inverse is what I've really done. So y equals the log base a of x is the same thing as x equals a to the y. Notice this is as an exponential equation and this is as a logarithm. Look at how this is set up though. My x is now on the left hand side, my y is on the right hand side. A was underneath a log here and now it's underneath a y here. So using that idea, this 9 equals the log base 10 of I. So what should happen now is my I should come over to the left hand side and my 10 should be my A and 9 should be my exponent. In other words, I've got this. It should be I, not x. So I equals 10 to the 9th, which is 1 billion, I believe. Well, let's try. I need redemption, guys. I need closure. So it's a 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah. All right, let's move on to the next one. All right, this one, you know what? I can tell you right now what the answer is. It's 0. How do I know? Well, it doesn't matter what the base is. If you're taking the log of 1, it's going to be 0, all right? So just watch for that. All right, this next one. Psychologist is studying the capacity of the human mind to process information. He has found the percentage of information one particular participant can recall after t months have passed can be modeled by this logarithmic function. What percentage of information is retained after 10 months? You know what? Just plug in 10 for your t. 10 plus 1 is 11. Hit your natural log button. And then once you figure that out, multiply that by 22. And then that result, subtract from 90. You've got your answer. I'm going to skip past this one if that's all right. But if you have questions, for sure, let me know. All right, this one, let's use this formula here that I've got. And we're going to convert the log base A of 15 equals 2 into an exponential equation. And that's going to jump right out at you for an answer. All right, here we've got 2 equals the log base 15 of A, equaling A equals 15 to, or being in the inverse of that, A equaling 15 to the square. So again, this is the converting a logarithm to exponential equation formula. So again, what happens is the 15 comes up, but it's still trapped underneath the 2. The A comes over to the left, the 2 comes over to the right. Long story short, 15 squared is going to be your answer, which I believe is 225. I did that off memory. Let's see if I'm right. What a memory I have. Moving on. This is that sound intensity. Okay, this time you do plug in 1995 for your I up here, unlike that last problem that I botched earlier. Sorry about that. And now I sub 0, that is 1. Okay, that's your base intensity. And then this guy here is, well, by base intensity, I'm talking about your threshold of sound, right? You call that a 1, and then 1995 in for this. So really, you're just taking 10 times the log of 1995. You'll have it. Okay, moving on. This one, we've already talked about. I'm skipping it if that's all right. And this one, okay, I'm going to show you a trick here. Give me just a second. All right, I am ready to unveil. So log of base 7 of 49, you can read it as this. This base here, 7, to what power is 49? Well, 7 squared is 49, so your answer is going to be 2. You can look at it that way. I'll go ahead and enter that in so you can, there you go. You can enter it in that way. If you're really into, and it doesn't always work that way, what if it's like 7 to the 49, negative 49, or actually that wouldn't be possible. 7 to the 49 to the negative 1 power, something weird like that. All right, if you really want to, you can do this. You can use what's called a change of base formula, where if you have the log base a of b, you can change it so you have the log of the big number up here divided by the log of this little base number down here. So in our case, we would take log base 7 of 49 is the log of 49 divided by the log of 7, bust that all out on a calculator, and you'll still get your answer of 2. So it's another way of looking at it. This next problem number 9 here, it's the same as we've seen before. Just plug in your 1259 in for your I, grind it out, you'll get it. And this last one, same one. It's like just the one we just got done. I think you guys will be set on this homework, but if you have questions, definitely get a hold of me.